So one problem that most developers encounter when they start working with threads are concurrency issues. And there's a whole range of concurrency issues that can crop up in multi-threaded applications. This is really why multi-threaded application programming is difficult. The first concurrency issue that we are going to talk about here is one called synchronization. And this is basically the problem of sharing some memory in Java. When you create different threads in Java, those threads can access the same object. And how they access that object can cause some kind of synchronization problems. And we are going to look at an example where we are going to see how two different threads accessing the same object can end up putting the object in an invalid state. And really what this boils down to is the idea that these threads don't have a separate copy of the data. And because they don't have a separate copy of the data, when the first thread is manipulating that data and the second thread manipulates that data, those things are going to cause some problems if they overlap or if they interleave. A good example of this would be if you have ever made the to-do list and you have shared it with someone and you haven't quite updated that to-do list. Maybe you have picked up a task on the to-do list and you started doing it, and then whoever you have shared the to-do list with is actually doing the same task at the same time. There is a synchronization issue there because you are both working on the same time or the same thing at the same time, but you haven't synchronized it. If you haven't come up with a formal way of saying, okay, I'm grabbing this task, so you should grab the next one down, then you might both end up doing the same thing. So let's take a look at an example of this in Java, just kind of an idea of how this could happen. I have got a really simple diagram here, and I'm showing thread A and thread B, and they are both accessing this object in the middle here that has some kind of count. And I have got the count initially set to 1 here. Now what can happen here is, let's say that thread A goes and access this object and is going to increment the count. So it is going to increase the count to +1, whatever it was +1. And let's say thread B is going to do the opposite. It's going to look at this object and it's going to decrement the count. So whatever it was, it is going to -1. Seems like this couldn't create a problem. So whatever scenario you can think of, thread A comes in, increases the count to 2, thread B comes in, decreases the count to 1. That is correct. But here's the issue. In Java, an increment operation is not atomic. What I mean by this is it is not the only step. There is potential for thread B to come in and do something in the middle of thread E's increment. And this has to do a lot with the way that a Java statement could be broken down into some bytecode that might be multiple statements. So for example, when we talk about increment really is not a single operation. What it really is get the value, add 1 to what the value was, and then store the value. So this basically are actually 3 operations. Get the value, increase the value, and then store the new value. And when you think about it that way, if thread A comes in and is going to increment the account on our objects, our account is 1. Thread A comes in and it says get the value. Then at the same time, or right after that, thread B comes in and it is going to decrement the object. It is going to decrease the count by 1. It says get the value. They are both going to be holding 1 for the value. Thread A increment the value, so it does 1 + 1 is 2, and then let's say it even stores it. So thread A will store a 2 in there, thread B will then come in and decrement the value, so it had a 1, it decreases by 1, so it is 0, and it will store 0. So now what's happened is, you have an increment and a decrement, but you have get 0 stored. So instead of it being 1, you actually gone down 1 to 0. And this is something that you really don't want in your code. So you need some way to synchronize this so that when thread A is accessing this count, that it prevents thread B. It says, wait a minute, let me finish what I'm doing. Let me treat my action as atomic, and then you can come in and do something and manipulate this object. Because if they are interleaving, if they are happening together, you can't predict what the result is going to be. It is going to depend on timing. And that's not something that you want in your multi-threaded application. And these are really the most difficult bugs to solve. If you haven't thought about this ahead of time, when this happens, if you can imagine, it is going to happen very rarely. But when it does, it's going to create a big mess that is going to be very difficult to detect and understand why it happened.